Now let's take a look on problem number 2 over here. We're gonna do the similar thing, but this one it use a wood beam, and this is the species of the wood, the Douglas fir south. This is the species of the wood, and the grade of that is grade number 1. What does it mean? So I require you guys to check for E and I in the AWS reference over here. What does it mean as well? What is the size of the wood mean? Now, if you open the reference, let me close some of that. If you open the reference AWC, oh my bad, this one should be AWC. You're gonna see that this one is the American Wood Council. And in this reference over here, you're gonna see some information related to the wood species. For example, the one we need to check for is the Douglas fir south. What you can do is that you go to Douglas fir south over here. And the one we need to calculate is a beam. So we're gonna use these three options. We're not gonna use this one because this one is for pause, which means column. So we're not gonna use these three options. So go back here, it say the grade number 1. So if I check here, I select number 1 for beam. So this is the value we need to check for, the modulus of elasticity. And because we need to check for E, so we don't need to use for E mean over here. This is the one we're not going to use. So E is actually this value. Just leave it here. We don't need to worry about that now. Let's go back here. Now, before we care about the E and I, let's check to see what type of reference figure we should use for this one. I think if you watch my video on the last lesson, you are familiar with this beam. This is very similar to the worksheet we did on the last lesson. So now let's open the shear moment deflection diagram, and then let's find the diagram that's similar to that. I have figure 29 over here, which is very similar to the one we have in our problem. So I'm gonna use figure 29 over here, and the delta max we have EWL to the power of 4 divided by 185 EI. So I know the formula now, and that one is approximately at 0.4215 L, 0.4215 L. So from here and also from here as well. So we know that the highest deflection around here and here. And because the question doesn't require us to calculate where is the location of the deflection, so we don't need to care about that for now. So now I'm gonna copy that here, and number 2, and I'm gonna modify that. This one is 185. Okay. So now let 5W. For W we have that one is 300 pound-foot. 300 pound-foot. And because for E and I we usually measure that by PSI, so we need to convert pound divided by foot over here to pound divided by inch. So equal to 300 pound, but this one will be 12 inch. So the value of this will equal to 300 divided by 12 is 25 pound inch. Okay, enter. And by the way, a tip for you is when you want to quickly enter the formula, you can click or equal. That is the shortcut or equal. You can create the equation insert over here. And now we have L. L equal to 20 feet. That will equal to 20 multiplied by 12 is to 40 inches. So now everything is in inches. Very easy to calculate now. Now we need to find for E. E, we go back here, go to the AWC, that is American Wood Council. Again, we're gonna go more detail when we move to wood design. However, for now, I'm just gonna show you how can you find the modulus of elasticity based on the species of the wood and based on the grade of the wood. Later on of this course, we're gonna discuss more about what are different species of the wood and how can we select the grade of the wood for different type of structure in construction. So for now, we know that that one is number one, and Douglas fir south. So we're gonna use the modulus of elasticity is 1,200,000 psi. This one of this one from bending all the way here, all of that are psi here. So I'm gonna write here 1,200,000 psi. Now we need to find for the I, and this one is bend on the x-axis. Bend on the x-axis. So you can go back here, and we need to check for the side here is 14 by 18. So I'm gonna look for 14 by 18 here, and the IX of 14 by 18 is 6029 inch to the power of 4. So I'm gonna have that one is I of X equal to 6029 inch to the power of 4. Okay, so I have all of the value over here. Now I just need to plug in into this formula. So I need to plug in into this formula. Oh, by the way, if you want to quickly create a copy of this slide, you need to click Control D, and then it will duplicate very fast like that. And then I'll just delete that and type equal to just copy this one again. So I have W is 29 multiplied for L. L I have is 240 to the power of 4. This one multiplied by E is 1,200,000 psi, and the I is 6029. So calculate the whole thing over here. I'm gonna have the value of the deflection is 0.062 inches. Now we can use the software to check the value for problem 1 and 2. So now let's try the software. Check for problem 1. So now you go here, go to soft. Let's open problem 1 first. Go to software, home, software, calculation, bending moment diagram. And I'm gonna model that. This one is 13 feet. 13. Here it have a pin and a roller. A pin at 0 and a roller at 13. And then the low here is A60. The low is start from A60. A60 start from 0 to 13. Okay. Now we need to provide the Young modulus. The Young modulus and the elastic modulus is just the same thing. It's just the same thing. This one they already have 29 multiplied to 10 to the power of 6. So by default, this one already the steel value over here. So we don't need to change that. Now we need to check for the IX over here. IX, we have IX, this one IX, so maybe let's put IX here. 96.3, so I'm gonna put 96.3 over here, enter. And for the A over here, we don't need to care about that actually, because we don't need to require to calculate that, so I keep that one as default. And then I will go to deflection over here, and if I look on the bottom over here, you're gonna see that one around negative 0.197. That is almost 0.2, similar to the one we calculated. So what I'm gonna do, I'm gonna put it here, and then I'm gonna take a screenshot here, and then I will paste that one here. Okay. And now we're gonna check for problem number 2. For problem number 2, let's open the software. The total length of this one is 20 by plus 20 is 40. So I'm gonna put 40 here. We have pin, roller, pin at 0, another pin at 20, another roller at 40. Okay. And then we have the uniform load is 300. So I'm gonna put 300 here, 300 from 0 to 40. Okay. And then I have the Young modulus or elastic modulus is this value 1,200,000,000 0. Okay. And then I have the IX is 6029. 6029. Okay. So now if I check the deflection over here, you're gonna see the deflection is around 0.062. That is the maximum deflection. Maybe let me put here. Okay. That is the deflection. So it matching with our manual calculation over here.